Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. Go to podcastinit.com/GoCD to learn more about their professional support services and enterprise add-ons. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host as usual is Tobias Macey, and today I'm interviewing Monty Taylor about Zuul, a platform that drives continuous integration, delivery, and deployment systems with a focus on project gating and interrelated projects. So, Monty, could you start by introducing yourself?
Yeah, hi. My name is Monty Taylor. I've been doing, in thinking about this beforehand, I did the quick mental math, and I've been developing in Python for 18 years now, which makes me seem just really, really old and crotchety, which comes out at times, which is kind of crazy. I work at Red Hat in the office of the CTO at the moment, which has been a really great thing. And in the general Python world, I work on this project that you may or may not have heard of called OpenStack. We do something about cloud software. Something cloud is basically how my wife describes what I work on. And I've been doing that for 8 years now, which is a terrifyingly long amount of time to work on a single effort. Like I can't think of any things I've done for that consistently that long in any other context. So I'm probably useless for the rest of the world. And the Zuul project we're going to talk today grew out of that work. I've been working on the CI and developer infrastructure systems for OpenStack since we put the project together. So if you have the time, I can always tell you old grandpa stories about back in the day, what we did, why we did it, and bore you senseless. It's all sorts of fun.
And do you remember how you first got introduced to Python?
I do actually. It's strangely topically relevant to Zuul as well. Back in 1999, it's always great to start any story with back in 1999. I was in Raleigh, North Carolina, which I grew up in the Raleigh-Durham area of North Carolina. And I moved away and I was back in town. And I have a background actually in theater, lighting and sound production. And so I was going with a friend of mine from there to a party of other theater people. And he said, hey, there's this guy that's going to be at the party. He's actually at his apartment named Jim Blair. And he also does computer stuff. That is, of course, as we all know, terrifying when you're in a non-tech, non-work environment for a friend in another context. Be like, hey, I've got this friend who does computers. You should talk to them, because it never works out. Like it's always like, your mom's friend's son who does something terrible or whatever. And so I was like, great, I'm so excited to talk to your computer friend, theater friend. And I got there, and it turned out that he was actually exceptionally smart and really good at computer things. And we hit it off immediately. And I was a Perl programmer at the time, and he mocked me for that life choice. And told me that I should really look into Python as a development platform as he found it better. And I was like, great, I will go look at that. And I immediately started shifting things that I was doing into working on Python. The first thing I did for real was I got a contract gig to write a Python library for the SNPP protocol, which is the simple network paging protocol. That somebody was going to use for something for a thing. And anyway, it's relevant to Zuul because it turns out Jim and I still work together, and he's basically the founder of Zuul as it is. So not only did that party introduce me to Python, also introduced me to Jim, and we've had a long running working relationship since then. So the one time when that oh my gosh, you've got to meet this computer friend of mine has actually worked out and been anything other than awful and scary. So also it was a long time ago. His Python thing that he showed me, he's like, hey, I wrote this thing in Python, and it was and again I have to preface this with it's 1999. He had written a system for listening to MP3s in his car, which wasn't really a thing he had. And it was exceptionally strange because it synced with the database of music in his house over this new networking protocol called 802.11b, which he had gotten his hands on some wireless routers. So he'd drive the car up to the parking lot, which is his spot on the parking lot, which is close enough to the apartment, and it would register, find the server and sync music down, and that was all written in Python, right? There was like just this giant computer in the trunk of the car, like had some relays connecting it to the battery, but that was all totally done in Python. I was like, great, wow, that's cool.
The days when you have too much free time on your hands.
I know, right? It's like that's just, and then several years later, as you just go to Best Buy and we don't even buy MP3 players anymore. Those are antiquated.
And so you've spent a fair amount of time working on Zuul, and you said that it got started fairly early on in your involvement with OpenStack. So can you discuss a bit about what the project is and how it got started?
Yeah, absolutely. So I actually get to really put on my grandpa hat here. So if you haven't heard of OpenStack itself, it's a Python-based cloud operating system that was originally started as a joint venture between Rackspace and NASA, which is the closest to space travel I'm probably ever going to get. The NASA folks are always like, well, we've got these satellites going to moons of Jupiter, and in 10 years, they're going to spit back a bunch of data. We need to be able to collect all of that data, but we don't want to just have servers running there. So they had a really great use case for elastic cloud resources. Anyway, that's a sort of rambling tangent. But I was at Rackspace at the time because I had been working on a project called Drizzle, which was a fork of MySQL that we started when we were working at Sun Microsystems after they bought us. I was at MySQL, then Sun bought us. And Brian Aker decided to make a fork of MySQL that ripped out a bunch of the crazy features that had gone in over the years and get back to basics. And then Sun, there's a reason that Sun got bought by Oracle a little bit after that, because Sun's response to that was, yeah, we totally want to fund that. That sounds like a great idea. Fork the thing we just bought for $1 billion. Great life and business decisions. Anyways, it worked out well for me. In Drizzle, I'm mentioning all that because in Drizzle, we had decided as a sort of development approach to have CI jobs for things. This is 2008, I guess it started out. Have CI jobs, and then we had a policy that your submission, your merge request, because we were using BZR and Launchpad at the time, your merge request had to pass the tests, right? It had to pass the CI tests before we'd land it. And a human in the team we would take turns sort of being the merge captain, and basically our job was take the merge request, submit its URL to the Jenkins job that would kick off things based on that. It would test them, and if they came back green, we would click the merge button. And that worked really well. We really liked it as a system because it allowed us to have the jobs always be green and to make sure that the code always worked. So if you came and grabbed the source code straight out of our trunk branch and ran make, it should always work for you, right? So you could always start development from the place of a working code base. The downside to that is that it was really boring work to be the merge captain. There's no way you can do it better. You're basically just clicking a button. And so when we started Oracle bought Sun, the Drizzle team didn't really feel like working at Oracle, and the Rackspace offered us a spot at Rackspace, which is why we were at Rackspace when the OpenStack project got started. And so they pulled me in, the Rackspace folks that were getting it kicked off, pulled me in to sort of help make sure that the open source side of it was well and get the project infrastructure set up. And so we decided to duplicate the process from the Drizzle side of things, but automate it more, right? So that we could automate the merge captain side of that out and just have all of those pieces be completely just automatic, so that somebody would do a review, they would approve it, it would go through testing, and if it passed the tests, it would merge. And that's how we started off since. From day one, the very first commit into any of the repos, once they became OpenStack, went through this. It's a process we refer to as gating, and it went through the gating system. The first version of this was very cobbled together. It was not an attractive system. I would not recommend the architecture that we used then to anybody. But there was a tool called Tarmac that the Canonical folks had written for Launchpad for sort of a similar idea. And it would go and grab approved merge requests from the queue on Launchpad, pull them down, run tests on them that you defined, and then either merge the merge request or not, or reject it. And we had a Jenkins job that ran it was a timed job that just ran over and over again. So it was basically in a loop. It was a Jenkins job, not because Jenkins was doing anything, but because we needed some web dashboard for people to be able to look at their build logs. And it basically just was a job that just ran the tarmac command to grab whatever was out there. That worked for the first year of OpenStack, though. It was actually great. It didn't really break very often. It was a pretty good system. But then OpenStack kept growing. It did not stay Rackspace and NASA for more than about 5 seconds. And we kind of had some meteoric growth, which is the person in charge of the project infrastructure is terrifying. It's the type of success that everybody wants except for the infrastructure team. You're like, yay, we're being successful. We have harder problems. So we wound up hiring Jim Blair, who I mentioned got me into Python in the first place, and we started actually doing some real engineering on the tooling at hand. And it took us, I think, about another year to get to the point where I got a phone call from Jim, and he was like, "Hey, so we're doing a bunch of work to kind of talk about bringing in Jim." Yeah, so then we brought in Jim Blair, the guy who introduced me to Python, and we started doing some real engineering. And about a year later, we were having a conversation, and he's like, "Hey, I've got this crazy idea. We've got these existing tools, and we're using them, and they're great, but they don't really understand the thing we're trying to do, which is that we want to make sure that we test all the patches correctly in between approval and merging them, right? Like this sort of gating thing. It wasn't really what the other tools were designed to do. It's like, what if we wrote a tool that actually wasn't just trying to configure something else that was designed for a different purpose in mind to get to do that, but just actually understood that was our goal? And more to the point, what if we apply the idea of pipelining and optimistic branch prediction from microprocessor design to the topic, right? So that we can create a virtual queue of changes that have been approved and that want to land, and we can test them in parallel to handle sort of the explosive growth of OpenStack. So we don't have to keep waiting. So we don't have to skip tests or do anything crazy like that. Keep running all of the testing that we have every time, but run it in parallel, but be able to run it in parallel correctly on what the state of the repository will be, right? So we're not going to test your patch. We're going to test what the repo would be if we merged your patch into the repo, which is where making a sort of a virtualized serial queue of changes comes into mind. Because if you have, say, 20 changes be approved in an hour, or in the chunk of time that it takes you to run one set of tests, then you have this real sort of race condition, an inherent race condition problem. Your testing, if you don't do that, isn't testing the resulting state of the world. So I was like, wow, that sounds like a great idea, Jim. We should definitely do that. Or more to the point, you should definitely do that. You can please go write that. That sounds like it'll be a great thing. And so that's basically the genesis of where this all came from, is the sort of initial use case of we want to, as correctly as possible, test the future states of these repositories, but not have to, the pathological case, of course, is that it then goes down to serial. You can only land one patch at a time, and you can start testing the next patch until the first patch has been landed. To make things more complicated, because that's not complicated enough, OpenStack from day one was, it started off as 2 repositories. By the time we were working on Zuul, I think it was probably at like 10 or something of that nature. But we'd had this idea, and it's, the microservices world has made this pattern, I think, much more prevalent. At the time, we thought it was just our craziness. But the idea of having the functionality split across multiple repositories that are each implementing a specific service of the overall product. The thing we ultimately want to test is the overall product, right? It's if Nova works, but it doesn't work together with Swift, then, that isn't as useful, right? So just testing Nova or just testing Swift, just testing any of the individual components in isolation isn't as great of a final outcome as testing the overall integrated whole. And I get into discussions with people from time to time, like, well, if you have proper API contracts and you test the API contract boundary, it should all work and you should be able to do it all in isolation. I'm like, well, yeah, you should be able to do that. But in the world is a dirty place, that's a great computer science theory. And in practice, stuff gets weird. And also when you're talking about an IaaS platform for cloud, it's not just about the API. So there's interactions, there's behaviors with the underlying infrastructure that should be in the API contract, but like, how do you define them? It gets weird. And so rather than stand on ceremony and say, yeah, we're gonna spend 5 years hyper defining API contract boundaries that no one's ever going to actually fully read the entire specification. We apply this. So that gets us to, in a very long-winded and sort of rambling way, sort of the basis, the fundamental of what Zuul is. It's a gating system. So it's there to, at its core, it's there to allow you to validate proposed changes to a system, and to do that across multiple repositories, with the idea that you might need to test these repositories together, and that virtual serial queue I was talking about, where we're gonna do that and then do it in parallel, can span projects, so that because the interrelationship of those projects is actually the tricky part. So we want to make sure, as we're testing the state of the system, if the patch were to land, that it's the state of the integrated system, not just the state of an individual repository. So it's that multi-repository gating is the bread and butter of Zuul. It's the thing that it does. It does lots of things, but that's its fundamental identity. That's what it is, and why it's the gatekeeper. Of course, Zuul being the gatekeeper is we're not the only people to have had that thought. The fine folks at Netflix have an edge gateway routing infrastructure, and there's also a JavaScript testing framework called Zuul for unit tests and functional tests and things of that nature. So there's a few different people who've had the great idea to use the name Zuul for something in relationship to the word gatekeeper. But I can say that we were the first of the three. And I don't want to point any fingers, but Jim and I did actually give a talk on OpenStack's Zuul at Netflix several months before they open sourced their Zuul. So, I claim dibs.
And one of the things that I really liked as I was looking through the documentation is the feature that you were discussing, as far as having the optimistic merges and then testing the resulting state, because fundamentally that's really the core and one of the most useful principles of continuous integration, is that you're actually testing the integrated state of the system, whereas a lot of the other services and platforms that purport to be CI will execute the tests against the state of a given branch, not necessarily what it looks like after everything's been merged, so that you can get a full clean set of tests, and then you go to merge, and then all of a sudden everything's broken because you didn't actually test what the final state will be, particularly given what you were saying of having the case where multiple people might be working on parallel branches and then decide to merge them back together at roughly the same time. And then, okay, what's the order of resolution for these? So having that built into the fundamental mechanics of the system makes it a lot more robust.
Exactly. And that's exactly you're exactly right about that. And that's the thing. And we found it to be exceptionally powerful. So in OpenStack, we have we're very fortunate. We have a lot of cloud resources at our disposal. Maybe have something to do with the fact that we're building a cloud operating system. So we have more available testing bandwidth than a lot of people do. Although I would say that our amount of it is it's the right one. And I wish that more companies and projects would fund their testing infrastructure. They would realize the power of funding that testing infrastructure well, rather than thinking of it as just as a cost, right? It really can be a powerful enabler. But because we have that, we actually test all of the patches that are proposed to OpenStack twice. This is a thing you can do with Zuul. It is not required. None of the things Zuul is very configurable, so you don't have to do any of the things I'm talking about. But we test your patch when you submit it, when you upload it into the review system, largely, and we test it largely as it is, and that's mostly as a way to help the other code reviewers. Right? So the people reviewing your code, it's kind of a waste of their time to review your code if it doesn't pass tests in the first time, and human time is valuable. We don't want to waste reviewer time with reviewing fundamentally broken patches. But then once the appropriate amount of reviewers have reviewed it and approved the patch for merging, then we do the gating and we run it again. And because we're running the test twice, in theory, you should expect that all of the tests in the gate side of it would work, right? We've already tested the patch before at our check layer, and that is actually not true, right? The amount of breakages that are caught at that second level is significant, and part of that is because we're a high volume project, but it's a really, we've been trying to think about how to quantify this so we could write like a more academic paper on the topic. So we might have to go do a bunch of data mining at some point. But we have at least anecdotally experienced that the system is providing a high amount of value and allows people to go fast, right? So you can, in fact, actually several weeks ago, Jess Frizzell, that works on Kubernetes things as well as other container, lots of things, tweeted out, she's like, what I really want is just a thing where I can just say, yes, merge this, and then have the bots merge it when it's ready to merge, right? And I'm like, well, yes, that's exactly what we've done. It's that desire. You want to just do your review, click the button, and not really have to worry about it at that point. Have the computers do the right thing for you, even if it means retesting that patch 7 times through automation because something ahead of it failed, and so you kick it out of the queue and you retry things. That's really boring for a human to do correctly, and a computer doesn't get bored, so it's fine. It's fine doing all that as correctly as you can. So yeah, you're exactly right about all that.
And your point about data mining, I'm curious about what sorts of information and metadata are collected automatically from Zuul, and the types of information that you can append and create in the process of running the various tests so that you can do some interesting data mining and collect some sort of development statistics to feed back into your overall cycles.
Yeah, so that's a great question. We actually collect a bunch of stuff, and I'm going to give a quick shout out to the OpenStack developer infrastructure. I'm going to mention a couple URLs in here. We run all of the developer infrastructure for OpenStack also as open source projects and as sort of open ops services. So all of our operations is open and public. We don't have private secret ops things other than a file of passwords that gets fed into Ansible and Puppet. But all of our Puppet and Ansible is all open, as are our monitoring systems and data collection systems. So it's all 100%. All of the data that we collect is available for anybody on the internet who wants to go mine it and look at it, because we're an open source project. It's all open. Anyway, amongst the things we do, we collect a bunch of stat type metrics. We stick them into a Graphite. We have a Graphite system. So we stats-d Graphite to collect things about our node pooling system. That's like, what are the build nodes? How are they doing? How many of them are we using? Things about success and failure rates. So that our systems are instrumented to stick stuff into graphite.openstack.org, which is an open Graphite. You can go dig into anybody can go dig into that if they want to. We have a dashboard for that, a set of dashboards for that using Grafana. So you can go to grafana.openstack.org and see the dashboards that we've put together with that data. But that's just sort of stats and metrics. There's a couple of other chunks that we collect. The biggest one is logging. So in a sort of traditional CI system, clearly you have the build log, right? Here's your the log of the script that you just ran, and here's your test output. These tests passed, these tests failed, etc. So we obviously collect that. But what we're testing is a cloud. So for integration testing for us, that means actually installing an entire OpenStack installation and then running tests against that running cloud. And so we actually also collect all of the operational logs for all of the services. So we collect sort of in any given job, we can collect as many logs as was produced by the running of that. Because if you want to debug why your patch didn't work, it may not, the relevant information may not be in the test case itself, because it might be just in an operational service log of libvirt, right? And so as a developer, you need to be able to do that, which is the same things that you're going to have to do as an operator of that service. So we have a Logstash Elasticsearch cluster, as well as sort of the base logs storage itself. So if you go to logstash.openstack.org, you can actually search through all of the stored logging of all of the clouds that were involved in all of the test runs that we did inside of the system. And we have some other, we've got some systems that, so as much as gating is awesome in a system like an OpenStack, there's a bunch of asynchronous processes, and race condition bugs can sneak in even with all of this perfect gating infrastructure. And so sometimes people's patches will still fail, not because of their patch, but because of a bug that only shows up one in every 1,000 runs, right? And so we actually have some data mining systems that run after a patch fails in the gate that will say, hey, we've done some Logstash queries, and we've noticed that you've hit this known race condition bug, or we think that you've hit that based on analyzing the logs. We've got some people right now that are starting to look at applying some AI and machine learning to those data sets to see if we can start doing some more advanced error detection and analysis and things of that nature. And that's been really nice that our data set is all public, because when people have come up and said, hey, I'm working on machine learning and I'd like to talk about how it can interface with CI. I'm like, we have 12, 14 terabytes of log data available at any given point in time that you can run your stuff on without needing to ask us for permission to do so. So people can experiment with that on their own. And if we come up with anything, we can incorporate it into the base systems as best we can. We also have a thing that was written. It's also a general tool. We use test runner called Test Repository, which was written by the folks at Canonical back in the day, that uses a test streaming output format called subunit, which is written to allow for streaming test results that are interleaved. And we had one of the people in the QA team write a tool called subunit to SQL that takes all of those test results after a thing and shoves all of them into a giant SQL database, so that people can start doing trend graphing on the results and see what's going on at the test case level. So there's a bunch of tools. You'll potentially notice that actually none of those tools are really specific to Zuul. It's like not that Zuul is doing those things, and that's actually a really important design choice that we've made, is that we don't want to add graphing to Zuul, right? That doesn't make any sense to us, because there are already things like Graphite and Kibana and Grafana and all of those things that do that job better. So we want to be a facilitator to use those actual tools that are out there, rather than sort of grow a whole bunch of bolt-ons onto Zuul itself. Oh yeah, so that also, we do also in Zuul collect build history, and we have some sort of real-time status dashboard. So there's a Zuul dashboard that will allow you to go look at historical job performance and things of that nature. But because of, and this is a thing that sort of trips people up from time to time when they're coming from like a Jenkins background, with the sort of just run tests on a given repo or in a given branch, the concept of green or red? Is the build, is the build running? Like, what's your job failure percentage over time? Like, how is it doing? Those are those are sort of meaningless concepts for us, because the entire idea is that it's a part of the normal developer process for tests to fail, but everything passes once it goes through the gate. So a given branch, it's always green. Like, there is no trend graph. But you might want to find things about over time. Is there a test that's causing people to fail in the gate more frequently, or things? So the data mining is sort of on a different axis. We try and collect as much of that data as we can, and let people sort of analyze it and figure out what's going on.
And one of the things that happened recently is that Zuul got spun out of the broader OpenStack umbrella to be its own project, and that sort of brings it more into the view of people who are looking to set up their own CI/CD systems, and that raises the question of how Zuul fits into that overall ecosystem, because there are so many other options available, such as GoCD, Jenkins that we've mentioned, Travis, Circle CI, any of the numerous hosted services or open source projects or commercial projects. And so I'm curious, for somebody who is in that market, what is it about Zuul that stands out? How does it compare in terms of the use cases that it enables? And lastly, I guess it obviously scales to very large systems, but what are the limitations in terms of somebody who's considering a very small workflow in terms of team size or project number or project size?
So first of all, I just want to say, we're really super excited about the making Zuul a top level project. It's been just in the last year, we released sort of version 3 of Zuul, and one of the most important parts of that is we took a bunch of feedback that we gotten from people. Zuul originally had basically just been written as a tool for the OpenStack project, and we didn't take on other people's use cases as primary use cases, right? It was there to serve the OpenStack project. If it could serve somebody else at the same time, cool. But that wasn't what our driving focus was, right? Our driving focus is make sure OpenStack can deliver its stuff. But we got enough interest from people, enough people trying to use it for their own use cases, and having trouble because we hadn't really designed it to be reused in that way, that we went and made it more general, right? We changed some of the design facets, but we also generalized it. So, and took on, this is now a project that is not just focused on the OpenStack project. That's just happens to be it's our largest user, but it's just one of the users, and we want to be able to elevate those other users to the same level of importance to the development team in terms of that. So that's been really exciting for us. So we have our own website, Zuul-ci.org is there, and we've got a bunch of things moving to sort of help solidify that story and to tell the story. And there's also people who assumed that Zuul would only let them use the workflow that the OpenStack project had decided on, or that you had to have an OpenStack cloud or things of that nature. And we want to make sure that it's clear to people that although we think that using it with an OpenStack cloud is the best choice because we like open source infrastructure, that's not a fundamental requirement for using Zuul. And so we want to tell that story to people. There is a great ecosystem out there of sort of CI/CD systems, and I think another important thing for us, or at least for me, I don't want to speak for other people. I do want to speak for other people, but I'm going to try and avoid doing that. I don't want to get into right. We've developed like this whole, the industry has sort of taken on the proprietary software mindset of everything being a competition, and I prefer vibrant ecosystems myself. I think it's great that Travis is there, that Jenkins is there, that GoCD and all of the other choices. I think that's good for everybody, that there's these choices, and that there are different systems that might meet people's needs in different ways. And so that's wonderful. And I want to, as best as possible, be complementary to systems where it makes sense, or whatnot. The thing that we covered earlier, the sort of multi-repository gating, is a feature that we have that just it is not available in other systems. So that is, if that is a thing that you are interested in, I without picking on anybody, because the other systems don't have it, because that's not the thing they're trying to give. Nobody's failing at offering that. It's just not an offering. If that's the thing that you want or you're interested in, we're the thing that you should be looking at. That's our primary purpose in life. There's other use cases, other ways to think about CI that we're not going to be as good at. We're not super well suited to having a thing that runs jobs. You can run periodic jobs on a branch, or you can just run post commit jobs. All that works, but you're not going to have as good of if that's your primary CI approach. We're probably not as pleasant a system. We sort of want to nudge you towards that gating model as much as possible. There's some other things about Zuul that I haven't even mentioned yet that fit into that, like why you'd think about us as opposed to one of the other ones. In writing Zuul, so Zuul v2 actually was essentially an external scheduler that triggered jobs on a fleet of backend Jenkins servers. So all of our jobs were defined as Jenkins jobs. We actually, before Zuul v3, we ran one of the world's largest Jenkins infrastructures. So we actually know a lot about Jenkins. We wrote Jenkins plugins. I still have core committer status in the Jenkins core. And it's a great project, and I really appreciate those guys and everything they've done for the world. It wound up being, given once we had Zuul doing its thing, that we were essentially using Jenkins as a remote code execution engine, so just to run remote shell scripts. And it's a little bit heavyweight for that. Like, we weren't using its plugins. We were minimizing the Jenkins plugins we were using for various reasons. And so in writing Zuul v3, we replaced Jenkins in the overall architecture with use of Ansible. Because we'd written a tool called Jenkins Job Builder, which allowed you to write Jenkins jobs in YAML and then have them be exploded out with some templating, and have them be exploded out into the actual Jenkins XML that would then get pushed into a Jenkins via the Jenkins API. And that Jenkins Job Builder YAML looks remarkably like Ansible in the first place. We didn't really want to write another remote code execution system, so we just adopted Ansible as the language of writing the tasks. Another one of the main features we added in v3 was sort of native multi-node jobs, and this is the other place where Ansible came in. Is, again, we're testing, our main first user is OpenStack. Testing that you can install a cloud on a single machine is a great way to do some functional testing, but most people aren't deploying an entire cloud operating system on a single computer. And so people really want to do testing jobs that span multiple nodes. And that's always tricky in a model where you have a build node that's attached to the sort of central server, and you run code on it. So by choosing Ansible, it allowed us to still have a simple way for people to express shell snippets that they wanted to run on machines, but also for them to be able to associate those with more than one machine. So run this command on machine 1, run this other command on machine 2, and then as part of the job definition in Zuul, basically say, for this job, when a patch is uploaded, I want you to run this job on this project, and this job essentially wants 4 machines that are going to be named these things, and it wants to run these Ansible playbooks against those. So that's basically what Zuul jobs are now for users, and so that sort of brings us to sort of another, depending on who you are and how you're thinking about things. We've been trying to think of things, and I've been saying the phrase, test it like you deploy it. We're trying to avoid having a lot of test infrastructure or testing CI explicit automation, and rather provide a facility to use your actual production automation in the testing context, right? So if I'm having to write complicated logic to install or deploy something at the testing layer, or to describe what that workflow is, then again, I may not actually be testing what production is going to do. What I ultimately want Zuul to be doing is testing proposed new states of production, so that if you do all that right at the gating level, and you set that up and you're testing using your actual production automation, you should be able to arrange things so that you can do continuous deployment of your code without without worrying about it. And in fact, we run most of our, not most, we run a lot of the systems that can handle it. Turns out some systems aren't written to handle a continuous delivery, continuous deployment system. And when we run other people's code and sometimes our own, it just hasn't been architected to roll out every second. But we run as much of our code for the OpenStack infrastructure systems continuously deployed. So like we land a patch to one of our repos, and it's getting rolled out the instant it lands. But that's because we're gating it. It's because we're doing that validation ahead of time, and we want to be able to expand the validity of that by letting you use your actual production automation as part of the testing workflow. So I think that would be one of the other focus points. We don't want domain specific automation for testing. We instead want you to write your actual production stuff and then use it. It gets, there's times in which that doesn't make sense. You probably don't have production automation to run unit tests. It's probably not a thing you have. So there's some amount of test specific logic that's always going to be inevitable. But also by using an existing system such as Ansible to describe that, we're also hopefully increasing the shared language between developers, testers, and operators. That if they're all using the same tools and language, then it's easier for them to co-collaborate and to figure out what's going on. Not really a big fan of the whole, well, here's the automation we used in testing, but they're using this other thing in production, and everybody hates each other, and so we want to try and facilitate that as much as possible. I think finally, and I told you I was going to try and do this in less than 10 hours and I was going to fail. Finally, we are both both designed to run as a public service on the internet. So like we run the OpenStack's Zuul runs completely on the open internet and has been designed for that use case from day one, right? It's not a back office system. It's an internet service. And it's also designed to be deployed locally, right? So it's fully open source. So a lot of the systems out there have one of those features, or two of them, or many of them, but most of them don't have all of them. Most of them either, if they're designed for full public, large at scale internet size, and you can deploy them internally, they may not be fully open source, or if they're or they may just be designed for internal use and they're really not appropriate for public, at scale. Like the scaling idea of it may be that you install 5 of them. The scaling story for Zuul is that Zuul is scalable, and we have yet to find the size of project that it can't handle. If you can push Zuul past its scaling limits, we'd love to talk to you, but we haven't found them yet. We have a really large first customer, so we're pretty confident in being able to say that it can handle the scale. Whatever, we are fortunate enough to have to deal with the scale problem ourselves. So we want to be able to give that to you. But you also mentioned a question which is very important to that. Scaling up, we absolutely can handle scaling up. We can handle as many. We're a multi-tenant system, so Zuul can handle a single Zuul installation. You could run it at your company and have every department have their own tenant rather than having each of the departments have to have their own Zuul. So we've designed it to be able to share resources for efficiency's sake. Scaling down is a really important one. We've been working on that a lot. We have some quick start guides. You can install Zuul all on one machine, but it is designed for scale, so it's not quite as simple to get started. That is a primary focus for us. We want to continue to make that easier. I'm actually working on building and publishing container images like literally right this week. So we want to be able to hand people things like Helm charts to make it, because it's a multi-service. I don't know if there's an official definition of microservices, and I'm not really crazy about the redefinition of distributed architecture as microservices. So it's a distributed network application, which means there's multiple processes that talk to each other over the network. If it makes people feel better to call that microservices, cool. But it is that. And so it's not going to be just apt-get install this one piece of software and start it, and it's all running. So we're working on making that scaled down story as best we can. We've added a bunch of sort of pluggable drivers in the V3 rework. So we have support for. We did not used to have support for predefined static nodes. Everything sort of came from dynamic cloud resources. We've got support for that now. So we're trying to get that sort of getting started. The get yourself going. I personally have a goal that I would like to be able to run a Zuul. I would like to be able to sensibly run a Zuul on my laptop for testing my personal projects. And have that not be crazy. Right now, that's a little bit much, but that is I want that goal to be easily met within the next year or so. You could do it; it'd just be more work. Like not from a resource perspective, it's just there's a little bit more to manage than I think is where we want to be ultimately. But it's definitely we have some of our non-OpenStack users out there running it in some pretty small environments. So we're not all of our users are sort of mega scale at this point. We do have some people with some smaller bits, and there's Red Hat. There's a team at Red Hat called that has a thing called Software Factory, which is not just a distribution of Zuul, but it includes Zuul in it. Also includes Garrett and a bunch of other things. But they've got a nice like installer. So if you just want to get going, you can grab Software Factory and install it, and it's got that sort of easy to get going story down. And that's wonderful. And I'm thrilled that team has made that stuff. We would like for that to be just as easy straight from the upstream. We don't necessarily want you have to rely on a vendor to get an easy version. We do want people to be able to provide it both as a service and as a sort of vendor software product to people, because we think there is a value add story there, both from a support and a services perspective. But we don't want your reason to go to a vendor giving you a Zuul to be that it's too hard to install. That seems really lame to us. So we want to fix that over time and make that story better.
And so in the architecture for the project, you've made some design choices that you mentioned, including using Ansible for the remote execution engine. And it looks like it currently only supports Git as the source code system for being able to pull down the patch sets. And I know that you used Zookeeper as the discovery and coordination mechanism for the node pool. And some of those are systems that people might want to swap out in their own instances. And so I'm curious how difficult that would be and what would be involved in replacing some of those different components for being able to customize an installation or a distribution of Zuul.
Yeah, that's a great question. So I'll start with Git because it's the easiest answer. It would be exceptionally difficult to replace Git with something else. When we first migrated to Git for OpenStack 7 years ago, we were pretty excited because everybody's like, "Hey, nobody knows BZR. Everybody's using Git. Move to Git because it's where the industry is." And we're like, "Great, so this will be fun. We'll get to learn everything there is to know about Git from all of the developers who know how it works already." And then we discovered that in fact nobody knows anything about Git, and so we had to go learn a whole bunch. Zuul is very deeply embedded with Git in the way that it does things. Now that said, we had a lovely chat with some folks about a year ago, and I think it's probably about time to catch up with them, who were interested in Zuul but were a Perforce shop. And the thing that we were going to investigate with them is whether the Perforce Git sort of gateway integration would be enough to let Zuul do what it needed to do without needing to learn as much about Perforce as it knows about Git. And go that way. So that was going to be our first. And so I imagine for most of the other distributed version control systems, we would probably first try and see if it's possible to for a translation layer to be sufficient. At the end of the day, it is all code. So I mean, there's certainly nothing to say that it couldn't be done, but it'd be a giant rethinking of some things. So for now, I would say that if you are on something that isn't Git, we're probably a stretch. for you. If you're a DVCS that can translate back and forth to Git, so that Zuul could clone you, via a translation layer and do all of its merging that way and have those results be okay. That's actually probably not too unreasonable to do. But if it's something like a subversion, no chance. It's just not. The things we're doing. It's not. I don't think it would be worth the effort on either side of the coin to try and get it into a system like that. The other ones, this Ansible, and then we've got Zookeeper. There's also some Gearman in there for job scheduling. Although we've got a plan to make the Gearman go away long term. Ansible is actually sort of the architecturally, and we've talked about this a couple times. Architecturally, there's nothing stopping us from replacing the Ansible execution layer with something else. On the other hand, one of the things we found, so like all of our config management for the OpenStack infrastructure systems is currently all in Puppet, and we've got some changes coming for that for us. But so we actually have our Zuul jobs. The Ansible playbook involved in running our tests is really simple. It's a thing that says run Puppet. So we're trying to sort of approach that in such a way of, if you're not really into doing deep Ansible stuff, that's okay. Like, it's one of the things I like about Ansible. You can just write shell scripts. You can do whatever you want to and just kind of see it as a very simple YAML way to describe run these tasks on these remote machines. And those tasks can be run Puppet or run Chef or run kubectl or whatever it is that your thing wants to do. I think there's some ideas people have had about some ways in which making that pluggable might be interesting. But I think we in general, and you'll find this refrain from us, Zuul has a complex job at its core, so we'd like to keep elements of it as simple and straightforward as we can until we can't, right? So we'll try, sort of like with the Git thing, the first stab will be, well, let's see, so you're on Mercurial, let's see if we can do Mercurial to Git translation at the CI layer and how acceptable that would be. So we'd probably want to work with somebody who wanted to use it, but with something that isn't Ansible, to see if Zuul's use of Ansible is hidden enough that it doesn't really matter, right? And if not, then it's just code, and we could have that conversation. And I think there's some ways in which that could be done that wouldn't be completely insane. But there's also some Ansible-isms. There's some pieces, so it'd have to be thought about for sure. The Zookeeper one is an interesting one because, especially these days with the popularity of Kubernetes, etcd comes up in questions from people a decent amount. And I have to tell a grandpa story here for a brief second. When we were looking at the options for what we're using Zookeeper for, and part of that involves distributed lock management, so that we can make sure that we have only one executor handling a task at a time, etc. At that point in time, etcd 3 hadn't been released. And the word from the etcd folks is that etcd 2 was that actually using it in the locking way we wanted to was inappropriate. Like that one should not use etcd for those tasks. So we didn't, and we went and we did Zookeeper, which is okay. Since then, etcd has actually grown that functionality, and it would be completely technically feasible to use Zookeeper to use etcd instead of Zookeeper for the ways in which we're using it. But we've so far made the choice that we don't want to make that back-end system pluggable, because we're a bit worried about getting the least common denominator between the two systems and having a system that doesn't work well on either Zookeeper or etcd, which is sometimes we want to be able to make use of those features. But it comes up from time to time for sure. And I'm sure it's not going to stop coming up from time to time. So that's one that definitely in conversations, but so far it hasn't been enough of a problem or an issue or a blocker for people. I think there was actually somebody who was investigating there's a Zookeeper proxy gateway for etcd that allows you to talk Zookeeper protocol to etcd, and I think somebody was exploring whether or not they could use that from within Zuul. But so that one's probably a bit harder. That said, there is inside of the code base an abstraction it's not an abstraction layer like we're going to abstract the differences between MySQL and Oracle, but like there is a class layer inside the code. So there is a place where one could obviously do that work. The thing that we're not sure about, especially as it goes with multi-node locking, is it's one of those things where everything works right until it doesn't, and the devil is in the failure cases. And we're pretty confident that we've gotten those worked out appropriately with Zookeeper, and I would be reluctant to have somebody just go off, replace it with etcd without the sort of benefit of we got to ram through ours in a really high load environment that's kind of harder to simulate elsewhere. And I would hate for people to not to be able to reap the benefit of the sort of large scale production scale testing that ours happened, that we have an upstream one that goes through. So it's, goes into the bucket of it would be possible, but I certainly wouldn't suggest to somebody that they go off on their own and do it. And if it's like that much of a blocker, then chatting with us upstream. Although there are people who have said, hey, we don't really want to use Zookeeper. We don't like that. And we've been like, well, we're not going to replace it anytime in the near future. And that hard blocker against Zookeeper goes away pretty quickly as well when people realize they don't really have to do a lot with it. So anyway, that's a very long-winded, and it's one of those. So most of those are it depends things. It is all Python, so you can always do whatever you want to with it, because Python is awesome like that. But I would recommend, at least at first, to the Zookeeper needs are pretty straightforward, and it's pretty simple to run one, considering it as one of the services of Zuul, rather than, hey, I'm gonna, like we had somebody that wanted etcd because they wanted to run it in a Kubernetes, and we're like, well, you actually shouldn't reuse the Kubernetes etcd for your applications, right? Like that's highly frowned upon from the people, and that was sort of the thing they were wanting to do. They wanted to reuse that existing etcd, and I was like, that's a bad idea. Like, don't do that. Like, that's if you want to run a second one inside of Kubernetes, but if you're going to run a second etcd inside of Kubernetes, there's no difference in doing that and running a second one for Zuul inside of running a Zookeeper inside of Kubernetes as well. So like, it's not from a here's your Helm chart to run Zuul perspective, it's not really that big of a win. Anyway, it's me rambling on this particular topic, but yeah, it's a thing but there are a bunch of places where we have put in explicit extension points. We have GitHub and both GitHub and Gerrit support inside of Zuul natively at this point. That's a pretty fleshed out interface. Same thing in our node pool system. We have support for OpenStack and static nodes, but we have patches written and in review for Amazon and Google and Azure. And there's a person who's going to be writing a Mac Stadium one. Like we've got there's drivers in all of the places where you would where it really is important to support multiple systems at the same time for Zuul to be useful to people. So it's not in all the cases, it's not out of the question for us to have a plugin structure for something, but we tend to be pretty conservative about which things we make pluggable so that the system has a coherence across installations. Oh, actually, that reminds me of a thing that we have that is so unique we don't really even fully know we're still learning how to use it ourselves, which is that job configuration for Zuul is in YAML files in Git repositories. And because Zuul's job is managing state in Git repositories, it loads all of that dynamically. Like test jobs are speculatively configured just like your patches are, which is all cool. But there's a corollary to that, which is that you can have a repository that just has some Zuul jobs in it, and those repositories of jobs can be directly shared between Zuul installations. So we have a standard library in a repository called Zuul jobs. That the expectation of that is that in another Zuul installation, so if you were to install it, that you could just point your Zuul directly at our Zuul jobs, our sort of central one that doesn't contain OpenStack specific jobs in it, that just sort of base things like here's how you run talks. And so we're trying to make it so that a collection of different Zuul installations won't just be like a construction kit that the operator makes a service that is whatever he wants it to be or he or she wants it to be, but instead that there is an end developer who is working on a project across a couple different Zuuls would have a similar experience in them at least. So we want there to be some coherency. So that's one of the reasons that we're conservative about which things we make pluggable. And we want to make sure that if there's something that's pluggable, that there's a consistent interface at the job layer so that the thing that the developer interacts with, I don't care so much if the experience is different for different operators, but we certainly want to make sure that the experience for different users, that if they're using a gate pipeline in a Zuul, that it works as they expect it to, and they have an expected behavior, and that jobs can depend on behavior and things of that nature. The idea of directly sharing job definitions in a sort of live, inherently CD manner across installations, that's new, right? Like that's not a normal thing yet. So the semantics of that and what that means for life we're discovering those every day. Oh, wow, we put in some information about configuring mirrors that really sure is a weird interface and doesn't make sense for other people. Maybe that shouldn't be in here or something, right? So it's a fun learning challenge.
And briefly, to your point of it's all just Python, I'm curious if you were to start the entire project over today, would you still make that language choice?
Wow. Oh, here we are, podcast.init, the Python thing. Probably, yeah. Honestly, it's been really great. We actually have talked about the possibility, since we are a distributed system that talks over the network, as one might call microservices, we are architected such that we could replace some of the pieces of the system with a different language. There's a couple times we've talked about replacing a few of them with C++. Just for scalability reasons, but actually we haven't actually hit any Python related scaling issues, and we're pretty pleased with it. I was a longtime Python programmer. Obviously, I'm pretty good at it. We've also with this, just as a quick shout out to the Python community, Zuul v3 is fully Python 3. It does not support Python 2 at all. So we're trying to sort of ride the modern Python wave, which is very exciting. We're currently working as far back as 3.5, but we do have some of our users are already deploying in production on 3.6 and don't have any problems with that. So that's exciting. I want us to bump them into 3.6. Because I think that the ordered dictionaries being ordered by default in 3.6 is a great feature and would allow us to remove the use of ordered dict and make the code cleaner. And I really want those F string format strings. But I could see there being there's times, and the typing in Python 3 has made some things nicer, but there are definitely times when you get into some really complicated things where having compiler type checking can be helpful. And in those times when we've hit places where we're like, wow, this is kind of hard to mentally deal with without some better compiler help on the things we've talked about bringing some C++ into the mix, but we haven't really done any of that, and I'm not sure that we ever will. But it's definitely allowed us to be very flexible and to get going sort of very very quickly. We've been very pleased with it. Incidentally, then I'm sure this is going to cause somebody who's listening to this to have a panic attack and run out of the room screaming. We are a multi-threaded Python application. So I want to tell anybody who says that you cannot run multi-threaded Python at scale, that is not true. It is a fundamentally false assertion. And as with many things that have to do with scaling and optimization, everyone should always be aware of premature optimization. You do have to be aware of what the GIL is going to do. But depending on what your application is, it may not really matter to you, or you can structure it in such a way that it makes sense. So that is a feature of how we are designed, and it confuses people sometimes because they've been taught over the years that you can't do threads in Python. But I'm here to tell you they work just fine. And at the few times when we've sort of had scale panics, like we've hit something, none of them have been GIL related. At no time has the GIL actually been the cause of any problems for us, and we are running at quite a large scale. So I'm pretty pleased with how Python's done for us as far as that goes.
Well, for anybody who wants to follow what you're up to or get in touch or ask any follow-on questions, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week I'm going to choose the Hitchhiker's Guide to the Galaxy series by Douglas Adams because they are fabulous books and I have enjoyed them multiple times and I'm revisiting them again recently. So I definitely recommend anybody who enjoys a good story to check them out. And so with that, I'll pass it to you, Monty. Do you have any picks this week?
Yeah, I first want to say your pick is great, and I need to go revisit them. It's been a while since I've read them. There was I remember very distinctly the scene where I can't remember which one it is, but is chasing a Chesterfield sofa across the plains of prehistoric Africa or whatever, and it's just always stuck with me as an image. I'm probably getting the details about that wrong. Picks from me. And this shouldn't surprise anybody who's been in the same room with me over the last year. But if you have not seen the Netflix show BoJack Horseman, I highly recommend it. I'm gonna put a sort of star on that, which is that if you haven't seen it, if you first start watching it, it may not seem like it's a particularly interesting or clever show. It may seem like just another Archer or another, wow, it's a an anti-hero that is drunk and wow, I don't really care. I promise you it gets really, really good.
All right. Well, I want to thank you very much for taking the time today to join me and discuss the work you're doing with Zuul. It's definitely a very interesting project and one that I'm considering for some of my own uses. So thank you for that. And I hope you enjoy the rest of your day.